I teach a machine learning theory course at Brown. Machine learning is a hard topic. It takes several months to a few years to master. However, you can learn faster if you know certain high-level concepts that help you absorb knowledge more rapidly and structure what you know better. I will give you 4 tips to do just that. Machine learning is an eclectic mix of linear algebra, calculus, computer science, probability, and statistics. So it's very math-heavy, and the equations can be intimidating. All too often, instructors throw complex equations or multiple lines of derivation onto the board, expecting students to immediately understand what's going on. In reality, however, it takes a lot of time and effort to really understand an equation. Unfortunately, instructors sometimes don't have enough time to explain every single equation in detail during the lectures because it takes too much time. So, it is sometimes up to you to put in some work and figure things out on your own. My approach is to spend a lot of time teaching students how to make sense of equations at the beginning of the term. My hope is that once we walk through a couple of examples together, they will learn the steps and be able to make sense of the equations themselves outside of class by the end of the term. This might be surprising to many, but mathematicians don't think in terms of mathematical symbols. They don't just dream up a formula or have equations or derivations floating around in their heads. They think in terms of words and concepts just like everyone else, and once they have an idea, they translate it into mathematical formulas. So first, you need to understand the idea or goal behind the equation, and you need to be able to explain it in words. For example, evaluation metrics in regression like the mean squared error, root mean squared error, or the mean absolute error all have a similar idea. These metrics measure the difference between the model's predicted values and the true values. The smaller the difference is, the more accurate our model. But this one idea can be translated to math in a couple of different ways, which is how we end up with 3 different metrics. Let me know in the comment section down below if you would like to learn more about evaluation metrics in regression and classification and the subtle differences on how one idea can be translated to math in various ways. Once we understand the idea behind the equation, we need to take a look at each term and symbol and make sure we understand what they represent. Let's take the example of the mean squared error. MSE on the left side is the mean squared error we want to calculate for a set of data points. One does not simply walk through the symbols and terms of the equation from left to right. Instead, you need to identify the key terms, the most important parts of the equation. You know you found the most important part of the equation when it expresses the core idea. In the case of the mean squared error, the core idea is expressed by yi minus yi prime, where yi is the value of the true label for point I and yi prime is the prediction made by our machine learning model. Yi minus yi prime is the difference between the true and the predicted labels. This is what the term error refers to in mean squared error. The difference is then squared for data point I, which is the squared part of mean squared error. The last term we need to cover is the first one, mean, in MSE, which is calculated for a set of points. To be more precise, we have m data points in our sample. We calculate the squared error for each, for I equals 1 to m, add all the differences as the sum symbol, and then calculate the mean divided by m. This is how, step by step, we translate the math idea into an equation. While the mean squared error is a relatively easy example, the same game can be played with any equation. Once you understand the conceptual idea or goal behind the equation, and you have figured out how that idea was translated to math, it is time to consider the edge or boundary cases. Edge cases are extreme situations that might require special attention, and they usually happen when terms in your equation reach a minimum or a maximum. In the case of the mean squared error, one edge case happens when yi is equal to yi prime for all data points I. In this case, the difference is 0, so the mean squared error is also 0. From this, we know that the MSE of a perfect regression model is 0. There is no other edge case in MSE because the difference can be arbitrarily large, but other equations can have not just one, but multiple edge cases to consider. Stick around until the end because the last tip will boost your understanding of machine learning models. It is really difficult to study alone. There are a ton of free resources and courses available online, but most people simply don't have the resolve to study alone, including myself. This is one of the main reasons why universities exist. The professors decide what they teach, so you don't have to comb through endless resources and make potentially uninformed or bad decisions on what you learn. Universities provide a space where you can form study groups with your peers and talk to teaching assistants and instructors when you struggle with something. Instructors also keep you accountable with the use of deadlines and grades. If you find yourself in a situation where you don't have a good study group or support system while you learn, check out my website dscv.llc. The link is on the screen and also in the video description. I'm offering training and tutoring services tailored to your needs. If you already follow a course, we can set up regular meetings to discuss the concepts or exercises you are struggling with. We can also come up with a list of topics you'd like to learn more about, and I will prepare pre-recorded videos with exercises on each topic. We can also find a project or case study that I will guide you through. I'm also happy to discuss other preferred learning methods you might have. Check out my website dscv.llc for more info and sign up for a free 30-minute introductory call to figure out how I can best support you. When you learn, it's pretty rare that you start with literally 0 lines of code. You usually have a starter code, maybe the outline of a class, and you have to complete certain methods, or you grab some code from the lecture notes or a manual. Whatever the situation is, you will need to make sense of that code before you start modifying it. A similar concept applies here as for equations. One does not simply read through the code line by line starting at the top. First, you need to understand the high-level structure of the code and then dig deeper as required. If, for example, you work with the machine learning pipeline, identify where in the code all the main steps of the pipeline are performed. These steps could be data exploration, preparing the dataset for machine learning, splitting and preprocessing, cross-validation to train various machine learning models, and making the final model interpretable. If you are implementing a machine learning model, for example, logistic regression with stochastic gradient descent, there might be a logistic regression class with methods like train, loss, predict, and accuracy. Certain parts of the code might contain unit tests or simple datasets to make sure the model is implemented correctly. Whatever the actual use case is, make sure you have a solid high-level understanding of the code structure first, and then dig deeper into the code. Machine learning models are some of the most complex numerical algorithms. It's not something you pick up over a weekend. It takes a lot of time and dedication to develop the mathematical and coding skills necessary to even begin to understand how these models work, let alone understand them so well that you are able to implement them from scratch using only maybe Python and NumPy. But once you do, a certain pattern emerges which is really neat. All machine learning models, from the simplest linear models to the most complex deep learning models, have only 3 ingredients. The 3 ingredients of any machine learning model are representation, loss, and optimizer. The representation is a function that converts the feature values of a data point into a single number prediction. The function can be as simple as a dot product between a weight vector and the feature values for linear regression, and as complex as a deep learning model with billions of parameters. Once you decide on a model representation, the next question is, what type of loss function do you want to minimize? Loss functions measure the error of your machine learning model's predictions on a training set, and you want to make sure that the loss is as small as possible. Several loss functions exist. For example, the 0-1 loss, the log loss, the mean squared error, and the hinge loss are some of the loss functions you can choose from. It depends on the problem you are trying to solve which one is the best. Finally, we have the optimizer. The optimizer is an algorithm that finds the parameters of the representation that minimizes the loss function. Some representations have what's called a closed-form solution, meaning that one can find the exact parameters that minimize the loss, like the least squares algorithm in linear regression. Other representations cannot be solved that easily, and they require approximate numerical solutions. Some examples include the various flavors of gradient descent and backpropagation. These three ingredients help you to arrange your knowledge of machine learning in a format that hopefully provides a lot of clarity. Check out my other videos to learn more about data science and visit my website dscv.llc if you think I can help with data science training and tutoring.